Hello students, this is Bhattacharjee Sir and I have come up with another video. Now on your screen you can see one equation is written and here 100 gram of FeSO4 is reacting with camenophore. Molarity of camenophore is given, but what will be the volume of the camenophore should be taken so that there should be a perfect reaction between FeSO4 and camenophore. Now what is the standard procedure? Let me explain this. First, you need to balance the equation. After balancing, you need to find number of moles for FeSO4 and of course for camenophore, and you need to calculate in terms of their molar ratio as follows. Let me do this. I have written down 2 camenophore, 8 H2SO4, 10 FeSO4. Remember it's a 10, okay? Then K2SO4, 2 MnSO4, 5 Fe2SO4 whole thrice, 8 H2O. Okay. Now calculate number of moles of FeSO4 and camenophore as follows. So I have calculated number of moles of camenophore as I have multiplied molarity into volume in liter. So number of moles will be calculated like that. And for FeSO4, given mass upon molar mass. So those number of moles have been calculated. Now, how to calculate exact volume? Let me show you. So first, what I have done, I have just taken the molar ratio of K-4 and FeSO4. It is actually coming out to be 2 is to 10. So it is a 2 is to 10. After that, I have written down number of moles here and number of moles here. So they should be the same molar ratio. So after calculating that, the volume will be coming out as follows. So the exact volume of camenophore required will be 0.0657 liter. Now you can see number of steps, complexity involved in this particular equation. First of all, I need to balance the equation properly. After that, I need to calculate moles separately. Then we need to take molar ratio and go through this process. It's a very lengthy process. Now, if I tell you this can be done in a single step, yes, and this can be done by law of chemical equivalence. So let's explain how it can be done very easily with the help of law of chemical equivalence. This law says that number of gram equivalent of all reactant and products are always same. Suppose I have taken one equation A plus B given C and D. So in that case, number of equivalent of A must be equal to the number of equivalent of B, must be equal to the number of equivalent of C and number of equivalent of D. Let me write it down. So this is our basic principle. Now based on this principle, let's see how those questions can be solved very easily in a single line. Now you can see a flowchart by which we can calculate number of equivalent from various data of equivalent. I'll use it while solving the numerical. So let's bring back that question which we could not solve in a single line. So let's see how it can be done. Now you can see I have got this equation back. Now 100 gram, okay, and molarity of this solution is given 2 molar and we are supposed to calculate volume, okay. Now see, in this case we can easily write number of gram equivalent for camenophore and for FeSO4 must be same. So how it can be written down? Let me show you. So here I have written it down. Now let me find out how number of equivalent of camenophore can be calculated. You can see in this graph or flow chart, the value I have written down is this molarity. Where it is molarity, here you can see the molarity value. It is not visible. Let me just underline on this. Here, this formula I am going to use. Okay. So for that reason, what I'll write, molarity is 2. Okay. and then n factor of this KMnO4. Now, how to calculate n factor of KMnO4? Already I have taught this. Let me show it again. It is a plus 7. Here it is plus 2. So you can see the difference in this case is 5. So this is the n factor. So I need to multiply by 5. Okay. After that, I need to write down, you can see volume. This is volume in liter. So volume in liter I have written down. Now number of equivalent of FeSO4, it is a gram is given. You can see this is the amount of the substance. So which formula I need to use? Let me see. This formula I need to use it. This formula. So by this I can reach number of moles. So in that case, mass is given, that is 100 gram. Okay. And molar mass of FeSO4 I have calculated earlier, 152 gram. Okay. Then I need to multiply with n factor. Now let's see what is the n factor here. You can see if I move from this point to that point, now see it is the oxidation state plus 2 and here oxidation state plus 3. So difference is 1. So n factor is 1. So into 1. Okay. Now let's calculate the volume. So here is the answer. Exactly same answer we have got. And you can see how easily we have done this calculation. First of all, we don't need to balance the equation. Second thing, we can do it in 2 lines or 3 lines. Let's take another example. Here is the equation. Of course, I haven't balanced it. Now, let's try to write down all the data given in the question. So, it is given 20 ml solution containing 0.2 gram impure H2SO4. So, it is 20 ml. Okay. And that is 0.2 gram. Okay. Now they are saying it is reacting with 0.316 gram of KMnO4 in a solution. Now we need to calculate purity of H2O2 in percentage. So in this case, we need to basically find out actual amount of H2O2. Remember, this much H2O2 is an impure substance. So we need to calculate what is the pure H2O2 required for this kind of reaction. So for that reason, let's equate both KMnO4 and H2O2 in terms of their number of equivalents. As you know, number of equivalents of KMnO4 must be equal to the number of equivalents of H2O2. Let's write it down. Now to calculate number of equivalent of KMnO4, which formula should I use? I should use this formula. Can come here, this formula that can reach here. Is it visible to you? Okay, let me write it down. Now you can see this is 0.316 gram is the given weight, that is this value. Okay, and molar mass of KMnO4 is 158 gram. Here whatever value they have given is a wrong value they have given, 158 gram. And now I need to multiply by n factor. You can see this n factor is visible here. So oxidation state of Mn here it is plus 7 and here it is a plus 2. So the difference you can find is 5. So multiplied by 5. For H2O2, how to calculate? I need to use this for same formula which is written down here. That is this formula. Now to calculate number of equivalent of H2O2, I need to consider amount of H2O2, that is pure amount of H2O2 is x grams. So I'm writing it down x, which I need to calculate that. And after that, I need to divide by the molar mass, and molar mass of H2O2 is 34 gram. Okay. And then I need to write down the n factor. Now how to calculate n factor of H2O2? This oxidation state is -1 and here you can see this is 0. So difference you'll find it. It is a 1. Okay. There will be little overlapping. Please don't mind 1. But there are since 2 atoms, I need to multiply by 2. So n factor is coming out to be 2. So this is the 2. Okay. Now if you calculate this particular equation, then x is coming out to be So the pure H2O2 required for this reaction is found out to be 0.17 gram. Now we need to calculate percentage of purity. Let me calculate that. So it's pure mass divided by impure mass into 100. So it's 0.17 gram divided by 0.2 into 100 is equal to 85%. So friend, today we have understood how number of equivalent can be wonderful tool to calculate many complicated equations without balancing or without any hassle. So I hope you understood that. And remember, this chart is very, very important. With the help of this chart, you can reach to number of equivalent from any set of data. So for today, this much only. So hope to see you in the next class. Till then, bye bye. Take care.